Hello, viewers at home. You're welcome to the next episode on problem solving under rotational dynamics of rigid bodies. We are still talking about the inertia, how to calculate inertia of different bodies about a different axis that is parallel to the axis through the center of what? Gravity, by using the parallel axis theorem. So we are trying to, in these problems we are solving, we are trying to look at the importance and the usefulness of the parallel axis theorem in solving problems in the world of rotation. So this question I have here is also talking about finding the inertia of what? Of this object called a disk about a particular point or about an axis that is parallel to the axis through the center of gravity. Now, if the question reads that a disk rotates about an axis through the edge, through the what? Edge, which is perpendicular to the what? To the plane of the what? Of the disk. That means maybe, assuming I have my disk like this, this is the disk. This is a disk. And this disk should have mass. The mass was not given, so we can just use M to represent the mass. And assuming I make a hole about the center of gravity, let's assume this is the center of gravity. And from this center, the disk should have a radius R. The disk should have what? A radius what? R. Now from this axis now, I can draw from this point, the center of gravity, I can draw what? An axis through the center of what? Gravity. Now, let me now decide to rotate this object about this axis. That is in this direction or in the other direction, anyhow I want it. So at this point, based on this rotation, I can then find the inertia through the center of what? Gravity. Or about this axis, which passes through the center of what? Gravity. And for a disk, like the last problem we solved, was the same thing talking about a disk. The moment of inertia of a disk through the center of gravity has always been known to be equals to half m(r) squared. That is the formula. You don't have to forget this. So that was why we gave those key points, those dictionary on what? On the formulas for moment of inertia of different objects about the center of gravity. The first one we gave was what? Was a ring. For a ring, the inertia through the center of gravity is given as mr squared. But for a disk, the inertia through the center of gravity is given as half mr what? Squared. Now, but this question now says that assuming instead of rotating the object about this axis through the center of gravity, we now want to rotate this object about an axis located at what? At the edge. Look at it. It says what? Through the edge. Perpendicular to the what? To the plane. This is the plane. This is the plane. I hope you can see it is the plane. So I want to make an axis that will be perpendicular to this plane. Let me call this axis A. Then I want to rotate this now object in this along this axis or about this axis. So by so rotating this object, I can equally find the inertia of this rotation about this new axis I have chosen. But if you observe, this axis A and this axis through the center of gravity called C, they are what? These two lines are parallel. And they are separated by what? By a distance of what? Distance of D. So therefore, based on the fact that the axis A and the axis C are parallel, we now have the right to find the inertia about this axis A by using the parallel axis theory. Remember that if the two axes are not parallel, then the parallel axis theorem cannot be used. So now watch this. And what does the parallel axis theorem say? According to the parallel axis theorem. According to who? The parallel axis theorem. What does it say? It says that the inertia about the axis A is equal to the inertia about the center of gravity plus what? The mass times what? The square of their what? Distance of what? Separation. Now, we know the inertia through the center of gravity. But what we don't know yet is the value of what? D. What is the value of D? Very simple. Look at this. You observe that distance from here to here is the same thing as distance from here to here, which is actually the radius. So my d is equals to what? R. We can now say where our d is equals to what? R. So replacing all these things in this formula, that now means that the inertia through the axis A will now be equals to, what is the inertia about the center of gravity? The inertia about the center of gravity was given as half m_r what? Squared. So I will induce this into this formula. And this now becomes half m_r squared plus, what do I have here? The mass m times, what is now d? My d is now r. It now becomes r what? Squared. So therefore, that means that the inertia about the axis A will now be equals to what? Half m_r squared plus m_r squared. So this is half of this, plus this is 1. That is just like saying 1 of this. Okay, for those who won't understand this or who find it difficult to understand what I'm doing here, okay, let me just write the final answer. This is inertia through A will now be equals to 3/2 m_r squared. If you add half plus 1 will give us this. But for those who didn't understand this, let us now move back to our mathematics. Now, if I want, this is what I have here is inertia about A is equals to half m_r squared plus m_r what? Squared. So that means that my inertia about the axis A will now be equals, look at this. These two terms, what is common here? M is common, isn't it? We bring out M. What do I have again here? R is what? R squared is common, so we now have R squared. Now I can now factorize by opening the bracket. Now I have taken away m_r squared from here. What remains here is just what? Half. Plus, what remains here is what? It's not 1? Yes. When you add half and 1, and then here, what will you get? You will get 3/2. So this now becomes, so the inertia about A is just what? It's just, you can say m_r squared by what? By 3/2. So this now implies when you put this properly well, it will give us 3/2 m_r what? Squared. So that was how I got to this point. So this question is not really asking us to carry out any calculation. They only wanted us to derive the formula. The formula for the what? For the moment of inertia about an axis located at the edge of a disk. About an axis located at the edge of the what? Disk. So in this case, so it means that we can only find this inertia when the mass is known and the what? And the radius of the disk is what? Given. But in this question, the mass was not given and the radius was not given. But it's a good one that one should know how you can find the inertia about any axis which is parallel to the what? Parallel to the axis that passes through the center of what? Gravity. And then separated by a distance of what? R, or distance of d, by using the parallel axis theory. We still have more questions to solve in this episode. So keep on subscribing and keep on getting more of these videos as we proceed along. Thank you.